Bismillahirrahmanirrahim. Assalamu alaikum dear viewers. I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So our today's lecture is about indoles, where we will study the general introduction of indoles and its synthesis along with its mechanism. So first of all, we come towards the indoles introduction. As you know that this is the pyrrole ring. Here nitrogen is attached with one hydrogen. This is called as pyrrole. And if we give the numbering system to this compound, it is 1, 2, 3, 4 and 5. Or you may also go along this direction, then 1, 2, 3, 4 and 5. And because it is symmetrical, so on either side it would have the same numbering system. And if the benzene ring gets fused with this pyrrole ring, then this new compound would be called as indole. So if the benzene gets fused with 2,3 position of the pyrrole ring, it gets converted into indole. If the nitrogen is at 1 position, then it is called as indole, and if here it is like this, or if the nitrogen is at position number 2, then it is called as, here it would be like this, then it would be called as isoindole. The only difference is here, in the case of indole, nitrogen is at position number 1, but in this case, in the case of isoindole, the nitrogen is at position number 2. So now we move towards its synthesis, that is via Fischer synthesis. So the Fischer synthesis first discovered in 1883. This is the Fischer synthesis and it was discovered in 1883 for the first time, and it involves the acid or Lewis acid catalyzed rearrangement of an aryl hydrazone with the elimination of ammonia. And let's take a general reaction. Here a benzene ring is attached with this compound NH and with double bond over here, and it is here it is R1 and it is R2. So under the presence of zinc iodide and heating condition, it gets converted into substituted indoles. And as you know that just beside the nitrogen there is 2 substituents. So here it is R1 and here it is R2. So via this route, this is called as Fischer synthesis. Now let's see its mechanism. Here there is R1 and here there are two hydrogens. So for the first step of its mechanism, where does it happen? The nitrogen lone pair, or you may also write down here, it attacks on this hydrogen, this double bond is shifted to this position and this is shifted to the nitrogen. Then it gets converted into hydrogen. Here this nitrogen also gets attached with one hydrogen. It is actually a reversible step. Then it is also reversible. Now under acidic conditions, this nitrogen also gets protonated. This nitrogen lone pair attacks on this proton and it gets converted into this product. Yes, you may also write it again. Here it gets, and then we get this one. Here it gets attached with two hydrogens with positive charge over it. Here it would get a positive charge. And here is a double bond. Now these double bonds gets rearranged. It is shifted to this position and a new bond would be generated between this carbon and this carbon. This bond would be shifted to this and this bond would be shifted to nitrogen to relieve its positive charge. All these steps are in fact reversible. So here a ring is generated or a new bond is created. Here a double bond is formed, this one with nitrogen and hydrogen. This NH2 is like this. Then the next carbon is attached with R2. Here it is. Or okay, you may also shift this double bond to this position because here the deficiency of this carbon would also be compensated like this. Now what does it actually happen that this hydrogen gets shifted to this nitrogen. This lone pair attacks on this hydrogen. It is shifted to this position and it is shifted to nitrogen. And then our next intermediate becomes like this. Here it is NH2, because one hydrogen is here and the other hydrogen, this would also be attached with nitrogen in the form of NH2. This moiety would become as it is. Now this lone pair attacks on this carbon and this bond is shifted to this nitrogen. And you see here a 5-membered ring is generated. 1, 2, 3, 4 and 5. This nitrogen becomes incorporated between this carbon here with R2. Here it is with R1. Here there are 2 hydrogens, NH2. And it gets like this. And here this NH or this NH2 is like this. Now because here you see that it is attached with 2 hydrogens. Now what does there happens that this attacks on this, or this lone pair of the nitrogen attracts this hydrogen and this bond shifted to nitrogen. Now this NH2 gets converted into NH3 with a positive charge over it. Here it is R2 and here R1. Now one hydrogen over here, it is shifted to this position and this is eliminated as ammonia. So this is the position where we see that the aryl hydrazone gets rearranged with the elimination of ammonia. Here the ammonia is eliminated, so we say that with the elimination of ammonia to get converted into indole. So here a double bond is being generated with the substituents over here, and you see that it is our final product, that is substituted indole. So this was the mechanism for the Fischer synthesis of indole. So thank you very much for watching the video. Please subscribe my channel and press bell icon. Allah Hafiz.